All right, everyone. Good morning. Hey, my daughter was sick today, and I'm not able to make it into school. I'm in here. It's like 7:40, trying to get this done. I'm doing something new today, and I am using the Screencast-O-Matic. Hopefully, you can see me. I think I can click back and forth. Anyway, I'm hoping that you can see this volume lab presentation that I've put together. This is very simple. I've done it very, very quickly. Um, when you walk into the class today, you'll be getting a packet, and the packet, let's see if I can switch back here. See if I can figure out how to switch back here. I've got 15 minutes to make this video, so let's go back to myself. Okay. Should get a packet that'll look like this. I know it's backwards for you because this is on a camera or whatever, but it looks like this. And you've got some safety stuff. You've got some materials. You got some steps to follow. Flip the paper over. More steps. A table. And another table. Okay? We're going to go over how to fill this out right now. Before we get started on going over the actual content and the lab that you're going to do, you're going to be working with glassware today. The glassware can be very dangerous. The glassware that we have is very fragile. If something breaks, please, 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 please let somebody know. Let whoever the sub is, a para, let one of the adults in the classroom know. Because obviously sharp glass is sharp, and glass splinters hurt really bad. I promise you nobody's going to be upset if you drop something and break it. I've broken my fair share of glassware. In fact, I dropped a test tube yesterday, shattered on the floor, no big deal. It kind of stinks because they cost a little bit of money, but you know what? It's okay. If something breaks, let somebody know. You're not going to be in trouble, okay? That's number one. Let the teacher or one of the paras or someone in the class, let them clean it up for you, okay? That's seriously important. We're also going to be working with food coloring, and so if you get food coloring on your clothing, it stains. Try not to let that happen. If food coloring spills on the ground or on your desk or whatever, I got paper towels in the back of the room. Just clean it up, okay? As long as there's no broken glass, clean up after yourself. That'll keep it from spreading and ruining people's clothes, especially on picture day. That'd be really unfortunate. And then the last thing that you'll see on your handout is no eating or drinking in the lab area. We're doing a lab today, and some of this glassware is pretty old and has been used for a lot longer than I've been around this building, and so I don't know how old it is. So that tells me I can't identify what's been in that glassware. Let's just keep food and drink away from it just as an extra precaution, okay? No food or drink while you're doing the lab. After the lab, after everybody's done, I don't care. Okay. The materials that you're going to need, there's actually two. There's one set on here, but there's another set of materials that you need that I'll go over. So let me go ahead and share this presentation with you. If I can figure it out. Ah, there we go. Okay, I think I'm in. Nope, I'm not. Sorry, y'all. I'm going to figure this out. It looks like there's a button right there. There we go. Did I click it? Okay, good, good. There's a button there that I should have been able to click, but it was covered up halfway. Okay, the volume lab. Here we go. Volume lab. This is what we're doing today. Happy Thursday. We're going to do a lab activity measuring volume. But first, what is volume? Well, that's a very good question. And volume is the amount of space that something takes up with a typo. The amount of space that something takes up. That's what it is. So for a regular shaped object, finding the volume is not hard. It's really easy. For example, a Kleenex box. If you want to find the volume of a Kleenex box, which is a rectangular prism, or let's say you have something cube shaped, it's easy. Length times width times height. You measure the length, you measure the width, you measure the height, you times it all together, you multiply it all together, and boom, you got your volume. So for a Kleenex box, it's fairly simple. For a Rubik's Cube, it's fairly simple. Okay. Let's say you want to measure the volume of a cylinder. My example here would be like you're trying to figure out displacement of an engine that you have. If you want to find the displacement of the engine, you want to know how much volume these cylinders hold. Well, it's not hard. There's an equation. Pi, 3.14, times the radius squared times height. Again, this is fairly simple stuff. Pi r squared times height. That's how you find the volume of a cylinder, okay? But let's say you want to measure the volume of, oh, our video didn't show up, that's okay. Let's say you want to find the volume of an irregular solid, something like a key. Well, there's no equation for finding the volume of a key. It doesn't happen. So we have to find a different method, and that method is displacement. Here's my video. Okay, here we go. Let's watch it.
Of irregularly shaped objects like this glass pebble here. I can't use a ruler and do length times width times height because it's got a curved surface. So a straight edge ruler is not going to work. So we're going to use what's called the water displacement method.
I'm pausing. Hold on. Okay, so let's come back to this video. So water displacement method.
I filled my graduated cylinder with water. I've got it flat on a surface. I'm at eye level. I'm going to measure to the bottom of the meniscus, and it is at 35 milliliters. So I've got my starting volume of 35 milliliters. I'm now going to drop in this pebble. Notice that the volume level has increased. It's not because I've added water, it's now because this marble is taking up space in this graduated cylinder. So it's displaced or moved the water molecules. So now we're reading more water in here. So I was at 35 and now I'm at 37 milliliters. So how much volume then is in that glass pebble? Well, again, what's the difference? I was at 35, now I'm at 37. What caused that volume to change? The marble. It took up 2 milliliters worth of space because 37 minus 35 is 2. So this glass pebble has 2 milliliters worth of stuff inside of it, where it takes up that much space. But milliliters...
All right, so I'm going to stop it there. So you take your initial measurement of how much water is in the graduated cylinder, you drop your item into the water, and as long as the item can go all the way underwater, it will displace a certain amount, and it will raise the water level. And then you take your final measurement after you've put the object in, and you figure out what the final measurement is. Okay. In this case, it started at 35, which is this line here. She put the glass pebble in, and it raised the water level by 2 milliliters. 2 milliliters. I'm trying to remember back to the number she said, but it raised it. And all you do is you take the final volume and you subtract the initial volume from it, and I think she
represents fluid. Is that pebble a fluid, or is it solid?
Okay, I don't know if she does. I thought she put up a video or an equation up here, but it's final minus initial equals the volume of the object that you're looking for. So that's how it works. Okay, you've done this before, I'm sure, in physical science class. You've done it probably a handful of times in other classes as well. So this should be review for you. If it's not, find someone around you and see if they can help you out. Okay. All right. So what's the lab? Well, there's two parts. The first part is measuring the volume of irregular solids, and I'm actually going to work this backwards. So this is on the second page of your handout. This is the second table, measuring the volume of an irregular solid. There are 6 items: a marble, a staple strip, a screw, a magnet, which is in a salsa jar, a nut, and a paper clip. They're all on the back cabinet, on the counter, sorry, on the counter, on the side by the windows. That's where they're at. They're back in the very back corner, in front of the back window. Okay, they're all on the counter there. You're going to gather the 6 items listed on the packet, and you're going to grab a graduated cylinder, which is on the other side of the sink from them. I have a whole stack of them, and you're going to grab the smallest one that all of the objects can fit into. So you can't grab the very smallest one, but you can grab sort of the medium-sized graduated cylinder, and you're going to put some water in it. And it doesn't matter how much, as long as it doesn't fill it up completely and the item can still go underwater. So you're going to want to fill it up roughly halfway, Okay. For the staple strip, it's kind of long, so you're going to want to make sure you have enough space that the staple strip can go all the way underwater. Okay. You're going to record the initial volume on the table. You're going to drop your item in. You're going to record the final volume, and then you'll do a little math to find the volume of the object. I think this one's pretty easy. If you have questions, ask someone around you. Okay. The test tube lab is a little more complicated. All right. The test tube lab is a little more complicated. There's a lot of moving parts here. The materials list is on the front page of the handout. The materials list says get 6 test tubes and masking tape. Honestly, you can skip the masking tape because all of them already should be labeled. You're going to fill a beaker, and I've got beakers sort of right in the center of the counter between the 2 middle sinks. There are beakers there. You're going to fill a beaker with water. You're going to actually fill 3 of them with about 50 milliliters of water. And then you're going to put food coloring in each one. And I've got food coloring on the front desk up by the front door. You're going to do 2 drops of red, 2 drops of yellow, and 2 drops of blue. So you'll have red water, blue water, and yellow water. Then you're going to go back to your table with your test tubes and the smallest graduated cylinder. And then you will follow steps 1 through 12. At the end of 12, you're going to fill out the table on the back of the first page. Okay, it's actually, I think it's really fun. It's not hard, but there are a lot of moving steps. If you get stuck, ask the teacher, ask someone around you, or worst case scenario, you can email me. I'll be checking my email as much as possible. I know that this probably won't stay up on the board. Maybe it will, but you can find my email on PowerSchool or whatever. I'm sure you can find it. So I'll be checking my email as much as possible. A faster response would be asking whoever the teacher is in the class, or finding someone around you that seems to know what they're doing if you get stuck. But if you can't find anybody or nobody knows, send me an email and I'll do my best to respond as quickly as I can. Okay? All right. Good luck, everyone, today. I hope you have fun. Let's see if I can shut this off now.